Hello. In today's programme, What's Your Language? We explain why your micro may need to learn a foreign tongue.
And we've a report from a school in Reading that's been experimenting with computers in the music classroom.
And why the RAF have been installing micros in air traffic control towers all over the country. Now, hands up, who thought the home video games machine was dead? Well, it isn't, at least according to Atari it's not. Last weekend at the first ever UK Atari computer show, among other things, Atari were launching a brand new £70 video games machine. Atari's president, Sam Tramiel, son of Chairman Jack, also revealed that later this year the company will be marketing a dedicated word processing system to compete directly in both price and performance with the best-selling Amstrad 8256. But most interest centred around Atari's newer 16-bit ST range, which now even has its own magazine. There it is, ST User. Compare if you dare, it said on the Atari stand over an Apple Macintosh, a 520 ST and a Commodore Amiga. Well, naturally the ST was running the bouncing ball programme fastest. Or was it? The Amiga was unnaturally slow. It was almost as if it was running some other programmes at the same time.
No, never. Atari were launching two new micros. First, an uprated version of the 520 called the 1040. This comes with a megabyte of RAM, built-in disk drive and a mouse. It sells for just £700. No, sorry, £900. Try again. That's if you want a monochrome monitor, or £1,100 if you want colour. And like the rest of the ST range, it comes with GEM built in on a ROM chip. The other new micro is a cheaper version of the 520, which is called the 520 STM. That rolls off the tongue nicely, doesn't it? That sells for £399, and it can be used with an ordinary domestic television. It comes with a cartridge port around the side here, but as yet there's no software available in cartridge form, and that means you've got to buy a disk drive as well, which of course pushes up the price. There was a lot of new software for the ST range at the show, and soon there'll be even more available when Atari launched this co-processor, which will allow, they say, the machines to be IBM compatible. But when we tried to run the IBM spreadsheet program Multiplan, it crashed straight away. Ah, that's sort of compatible. Well, obviously there's a few bugs still to be sorted out. There were some impressive graphics packages, though, and some language software like this C compiler here. More about C later in the program. And of course, there were plenty of games. One that particularly impressed us was this illustrated adventure called The Pawn from Rainbird. Well, it's like most adventure games, but it's got a very sophisticated parser. A parser is the part of the program that understands what you type in. For example, look at this sentence here. Put the key in the hat on the tree stump. Now, taken in isolation, that could mean two things. Put the key that is in the hat onto the tree stump, or put the key into the hat on the tree stump. Now, most adventure games would hiccup loudly, but this one knows from the context there's no hat on the tree stump, so I can only mean one thing, and it interprets it as the blue key is now on the tree stump. It knows what I mean. The game is full of very nice little touches. There's an on-screen editor, which means that if I'd mistyped just one letter in that sentence, I wouldn't have to type it in all over again. And, well, we've all seen pull-down menus, but what about this? They've redesigned them as pull-down scrolls. Very nice. And when you let go of them, they roll back up. But best of all are the graphics. Nice one, Rainbird. And now here's Lesley again with a story that starts in the peace and quiet of the Shropshire countryside.
Bottom approach, Charlie Tango Sierra 11, request low airspace radar service en route for Lucas.
Charlie Tango Sierra 11, Cotham approach. What is your position, heading and level?
Charlie Tango Sierra 11 is 10 miles to northeast of Finningley. Heading 355, flight level 45.
Charlie 11, for identification, turn left, heading 325.
Turn left under heading 325, Charlie 11. Charlie 11 is steady heading 325.
Charlie 11 is identified 25 miles southwest of Cottam under radar advisory flight level 45. Resume under own navigation to Lucas.
Cottam, Charlie Tango Tango 80. Air test complete. Request recovery to Cottam.
Charlie 80, set QFE 100... Wait. Charlie 11, avoiding action, turn right, heading 030, pop-up traffic at 11 o'clock, range 2 miles, crossing left to right. Charlie 11, correction, turn left, heading 270.
Cottam approach, Charlie 11 with lighted aboard on EMS.
Well, I'm very glad this isn't the real thing. I'm not doing very well on one of the RAF's air traffic control simulators. That real air miss was staged for us by 2 very experienced pilots. They use this facility to give student air traffickers a taste of the real thing. It's driven by a £2 million mainframe computer, and it uses a lot of people as well. To give just 4 students a chance to practice, you need 4 fake pilots, 4 instructors to monitor their progress, 2 supervisors, plus all the hardware and software support staff. The only other way to give them practice is to let them loose in the real control tower here at RAF Shawbury, and then to fly anything up to 6 jet provosts in the sky around for them. Both methods are extremely expensive. It's reckoned to cost around £86,000 to train 1 air traffic controller. But in a job where 1 mistake can mean utter disaster, it's essential that the students get maximum benefit each time they practice.
It's a fairly dramatic jump from the theory in a classroom to going into the simulators and actually practicing the skills that we have taught them.
There's a tremendous amount of pressure, isn't there, in that simulator room?
Yes, very much so. And it's because of that that it was recognised that some midway point was needed, and it was identified that possibly microcomputers could bridge the gap.
The Air Force initially approached outside companies to write training software for them, but were quoted prices in the region of £250,000. So, the software now in use was written by the staff at Shawbury on their own home micros.
Turn right, heading 200.
The computer imitates a radar display, and there are various exercises graded to match the stages of training.
Turn left.
The early exercises are simple, such as directing an aircraft to overfly a point on the screen. Well, the exercises are designed to be used by 2 students working together. I've been joined by a student on the current course, Dave Vardy. Dave, you're taking the role of the pilot, aren't you?
I am, yes.
Sounds like I'm taking the role of the air traffic controller. Right, what have I got up on the screen here, and what's it telling me?
And what you're trying to achieve now is that's your aircraft. You're trying to bring him into the centre of the airfield, which is there, avoiding all other aircraft on the screen by at least 5 miles.
Right.
That is a one to conflict with shortly.
Yeah.
But you can tell by the length of the tail, because that is longer than that one, that is a faster aircraft.
You've got to take all these things into consideration when
Yes.
you make your decision about which way to turn your aircraft when you take the avoiding action.
You do, but with this facility, there's a pause button, so you actually stop and think of what to do.
Now, of course, on the simulator you can't do
No,
that. It's
no,
all
no.
happening in real time.
That's right. You've got to decide what to do.
OK, well,
Straight
shall
away.
I try and make a decision? The first thing I've got to decide, really, is if these 2 aircraft were going, where would they actually collide?
Yes.
And then try and avoid that point. Right, I'm going to turn my aircraft left. Can you turn it left for
You
me?
can turn it left. Onto what heading?
Onto what heading, the man said?
staying
040.
040.
Yeah.
It's now turning left.
And will I now see a result of the decision that I've made?
Yes, we'll also put on fast update, so you can see quickly the effect of your turn on the aircraft.
Right. Did I make a good decision there?
You kept well away from it, yes.
How far away do you actually have to keep to...
You need to keep at least 5 miles.
Can you check that as well?
You can, and a 5-mile ring will appear around your aircraft.
Yeah. So really, you're in control of the micro, whereas the simulator would be in control of you.
Turn left, heading 280.
Since the introduction of the micros, there's been a marked improvement in the pass rate at Shawbury. and at least now students can make their mistakes in private. The RAF are now planning to install a micro in every control tower in the country.
Here, for example, we have the kit that would be installed down at RAF St Morgan. St Morgan is based in Cornwall, and here you can see the outline of Cornwall, Land's End at the tip, and St Morgan is in the centre of the screen. Their normal day-to-day role is controlling fairly slow-moving maritime aircraft. However, several times during the year they get detachments of fast jet aircraft, and obviously there are different control procedures that the air traffic controllers have to adapt. We can set up any situation that they want, for example 6 tornadoes running in over Land's End, and allow the controllers to practice all the skills and procedures necessary to land those aircraft at RAF St Morgan.
The basic course here at Shawbury lasts just 16 weeks, but the air traffickers that they turn out are acknowledged to be the best in the world. So, in the interests of preserving their reputation, I shall be taking the next flight purely as a passenger.
That training software at RAF Shawbury was originally written in the computer language BASIC. Now, most micros come with BASIC built in. It's popular because it's fairly easy to understand. Well, here, for example, is part of one of the listings from the Shawbury programme, and there we are, you can see it's even got English words in it like if, print, and input, and so on. Of course, the microprocessor chip inside the computer can only carry out very simple instructions like comparing two numbers or moving a number from one part of memory to another. So when you run a BASIC program, not when you type it in, but when you run it, it's converted into those simple instructions, or what's called machine code. Now, although the machine code is very fast, the translation process takes some time, so BASIC runs rather slowly. But of course, there are other languages you can use on a micro. We'll have a quick look at a few, starting with PASCAL. Now, the top listing over here is in BASIC, and the bottom one is PASCAL. And both of these are programs to multiply two numbers together and print out the result on the screen. Have a look at the BASIC first. Well, the first three lines we've got here, line 10, 20 and 30, just set up three variables. A is a number, B is a number, and C is the answer of A times B. Now, line 40 here prints out a bit of text, the answer equals, and the result C. Line 50 just ends the program. Now, the PASCAL listing, first of all, you notice that PASCAL hasn't got the line numbers that BASIC has. This doesn't seem to be working, but never mind. Hasn't got any line numbers, none of those 10, 20s, 30s and so on. Also at the top here, the program has to have a name. In this case, it's called multiply. And there are the variables here defined at the top. Variables A, B and C, those are the letters we're going to use, and they're integers, they're whole numbers. Then here comes the program. It's surrounded with these begin and end markers. And the guts of the program in the middle here, much the same as the BASIC, except they use the word write line instead of print. Now, the major difference for the programmer is it makes you think in an ordered manner. Once a program segment is written, you've got to think of it as a block. You can't just dive into the middle as you can with BASIC. Now, PASCAL is being pushed as a very good language for education because it forces you to think in that structured way. But there's nothing to stop it being used for other applications. For example, it's one of the in-house programming languages for Apple computers.
Logo is a language that was specifically designed for education, and it's often used with a turtle like this. It's particularly good for teaching the simple concepts of programming and mathematics. At the same time, it protects the user from some of the raw edges of computers. Now, it can also be used to produce screen graphics. And this complex pattern here is the result of a very simple program. And it shows very well how Logo enables you to build a program step by step. The basis for this pattern is a square. So the first thing you do is define your square. You do that by saying repeat 4 times the action of going forward by the length you're going to go forward. You haven't yet stated what that is. And when you've done that, you turn left 90 degrees. Repeat that 4 times and you've got yourself a square. So then you can incorporate the square into the program, and the program reads here, repeat 36 times the square, and it already knows about that. Now you define the size, it's going to be side 200, and after each square, turn left by 10 degrees, and then you repeat that 36 times. And if you see the programme running, you'll see that actually its makeup is very self-evident. There you've got 36 squares turning themselves into a circle.
Now, one of my favourite languages is Forth. It's available for most micros, including the Electron here. Forth was originally devised to control radio telescopes like this one in Kitt Peak, Arizona. But these days it's used for everything from washing machines to the computer control of movie cameras, for instance in the film Star Wars. Here's how it works. If I type in this word V-list, I get a complete list of the Forth vocabulary, all the words that Forth understands. In fact, I'll hold it there. All of these down here are built-in Forth words, standard Forth words, except for this one here, hi, which is one that I made up myself. Now, if I type in hi, you'll see what it does. Prints a friendly greeting here, hello and welcome to Micro Live. Now, the beauty of Forth is you can build up new words using the words it already knows. So that's what I'll do. I'll define a new word which I'll call big high. Definition starts with a colon. The word is big high. What do I mean by that? Well, 100 times, starting at 0, do the following things. Just do that high program, print out the message, and that's a loop. And that is the end of the definition, and that's a semicolon. Now, as soon as I press the return key, that little program is turned instantly into machine code. Shazam. OK, it says, what next? Well, next we'll do it by just typing in big high, and there we are, very friendly greeting 100 times. Big high is now part of the Forth vocabulary. So you see, Forth can be extended to do whatever particularly interests you. Traditional software writing involves the programmer in breaking down a problem into manageable procedures. But an alternative approach, well, for some applications at least, is to chuck the problem to the computer and leave the machine to sort it out. And for that, you need a language like Prolog. Now, Prolog stands for Programming in Logic, and this is the version available for the Spectrum. Right, well, I've been telling the computer here about a bicycle. For example, I've said in the program, the electric flex is part of the lighting system. The hub is part of the wheel, the gear cog is part of the wheel, and the spoke is part of the wheel. And I've also told the machine about the relationship of those parts. For example, X is part of a bicycle if X is part of the wheel. Makes sense, doesn't it? And down here, I've typed in a question. Is the hub part of the bicycle? Now, I've not explicitly told the computer that it is, but I'll press enter, see what it makes of it. The machine goes away, and yes, it correctly infers from the rules I've given it. The answer is yes, a hub is part of a bicycle.
A lot of applications nowadays are being written in a language called C. It's very fast and it's portable. And that means that you can run a C program easily on a range of machines. Here's a listing of a simple C program on the Nimbus to print a table of temperature conversions from Celsius to Fahrenheit. Now, this was all typed in on a word processor. To turn it into a program that the Nimbus can run, it has to be compiled. That means running another program that converts the text into Nimbus machine code. But this listing could be compiled to run on a number of machines, and that's what makes it portable.
So, which is the best language? Well, unless you're a professional programmer or you want to do a very specific task, one general-purpose language like BASIC will serve almost all your needs. Now, recently it's become fashionable to knock BASIC. People say it leads to bad, unstructured programming habits. But BASIC can be used in a structured way, and it's fine for most applications. But of course, it's horses for courses. Hugh Farringdon School in Reading. 650 pupils aged between 11 and 18, and the location of an important experiment in education. Claire Tester, the school's head of music, has been taking part in a research project with Reading University. The aim is to discover whether a music-playing home computer is fit to join conventional musical instruments in her classroom.
Right, 1Z. What I'm going to ask you to do today is the next part of our project. You're going to make up a melody that you can repeat over and over again. The only rules are, it must last for 4 beats, and you may only use the 5 notes on the board, E, F, G, B and C. Got that? Right. Will you please go to the instruments that you're using? And you've got 1 minute to make up something really interesting from now.
The The interesting thing about Claire's work is the way she's integrated the computer with the more traditional instruments in the classroom.
Right, and stop. Thank you. Beat us down. Right, do we have any brave people who are going to play us their tune? Good, lots of you. Right, let's have Alison, Kathy, Mark. The rest of you listen carefully because we've got to choose one of these. OK, Alison, would you like to play yours twice now, please? Thank you. Kathy, now let's hear yours. Another good one. Mark. Difficult choice. OK, who preferred Alison's? Good. A few of you. Hands down. Kathy. Good. Hands down. Mark. Right, that's obviously the majority, isn't it? Right, hands down. Mark's is the first tune that we're going to use in our computer piece.
The computer has been specially designed for creating music.
When using the composing program, the computer will take in any number of up to 8 parts that you program into it, and then it will play it back for you. It's very simple to actually program. There's a selection of the note values here. Then here we have a conventional computer keyboard. Here is a piano keyboard, which you can use either of these to program the notes. For example, I'm going to use some crotchets. I'm going to program in, using the piano keyboard, a series of notes. Now the computer will play that back for me. Now that sound that you've heard is a sound that the computer itself has selected. I don't have to use that sound. The computer has 46 pre-recorded sounds of its own. Among these are instrumental sounds, or it has a large number of actual sound effects. Not only will it play back to you any of the melodies that you put into it, but it's a very simple operation to edit the melodies that you actually write, which means the composition can be changed very quickly. When you're finally happy with this, at the touch of a button, the whole thing will print out.
When it comes to printing the notes, it scores badly. Here it's making heavy weather of just producing one line of a stave.
OK, Mark, now we're going to program your melody into the computer. So yours will be the first one in our composition. And the first thing you need to use are semiquavers. CF. Quaver. G. Crotchet. E. Quavers. GC. Crotchet. B. Good. Now make it play for us.
The computer's better because it can store things longer in its memory than we could. So if we had a couple of weeks to remember it, we wouldn't have remembered it in a couple of weeks.
It's a bit of a shortcut because you're using like a guitar or a drum and playing it on a keyboard. I would prefer to learn how to play the instruments. I think it's better than actually playing it on a keyboard.
When we first got the computer, I thought, well, all the good musicians and everything will take over the job of working it, but it's easy to work and everybody was allowed to have a go.
What I think is the only disadvantage with the computer, and that is that it will only display and/or print one part at a time, even though it can play up to 8 simultaneously. Now, the first years created a composition that was really quite complex, and it was important for them to know what went on in the composition and to be able to view it as a whole, which of course we couldn't do. So they created a score of their own, using their own symbols. They used all sorts of things from hands to traffic lights, and it meant that although it was a rough idea, they could get an overall picture of the composition. first had the computer, we used it virtually non-stop. But interestingly enough, they did begin to miss playing the music for themselves after a while, which meant that we came up with a balance of actually playing the instruments on top of the computer in the background.
With the introduction of the new GCSE music syllabus, greater emphasis is being placed on creative composition. But until now, creativity has been stifled by the need to acquire playing skills. Now, using the computer, any child can play a piano, organ, trombone or drums and express creative ideas.
Ladies and gentlemen, welcome to the first public performance of a very important composition created by 1Z. Every note that you see and hear has been composed by them using a combination of a computer and live instruments.
I like playing live in the middle because if we didn't, the computer would have sort of been taken over.
I think an excellent way of assessing the success of any new teaching aid is to ask yourself the question, would I still use it if I had to carry it up 3 flights of stairs? With the music computer, the answer is definitely yes. It's added a completely new dimension to the teaching of music in this school.
And if you can find one, you can buy that music computer for £299. Yamaha tell us that there are very few left in the country, but they will be marketing a new but more expensive version in a couple of months' time. Now, much cheaper is this device here at £60. It's an add-on for the Commodore 64 called the Anirog Voice Master, and it lets you hum tunes into your micro, and then it reproduces the tune in a variety of instrumental voices and displays the musical notation on the screen. In fact, it does everything except teach you to sing, unfortunately, as you'll hear right now. Here we go. Da 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 da. That's enough of that, Fred. Oh, sorry, it's very... No, stop. That's it. I'll just play that back for you so you can hear how sensitive it is. It doesn't sound at all like Happy Birthday. The problem is that it doesn't hear those notes in context of a song. It just hears the notes and tries to assess the nearest one. It's got a very good edit facility, but I think in the case of this, there's only one thing to do with it. Stop. No. 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 Thank you. I'm going to speed it up. That'll help.
Well, Neil Point, thank you very much indeed. Next week is the last programme in the present series, as music lovers will be glad to hear. We'll be looking at a new flight simulator game that's been designed to run on 2 home computers linked together. We'll be comparing the speeds of some of the latest micros, and we'll have a report on a British success story. Yes, there is one, the new transputer chip from Inmos. But until then, thank you very much. Goodbye.